Welcome to another episode of React Roundup. On the panel today, we've got me, Thomas Aylott. Hello! And as well as Dave.
Hello.
And Lucas.
Hello, everybody.
And we actually have a guest this week, Christoffer Niska.
Hey, folks, I just want to let you know quickly about Netlify. Netlify is a really cool system for hosting what are traditionally known as static sites. However, the real benefit that I've been finding is that I don't have to mess with a back end. I can just set things up. I build the website out. I've been using a system called 11DJS, and you just deploy it. And then anything that you have that you want to do, you can do on the front end. So if you want to pull in some kind of database with Firebase or something else, if you want to collect form data, Netlify provides all kinds of services that make it easy to do all that stuff. If you're trying to do serverless, they have a really, really neat serverless setup that will allow you to deploy your websites without having to deploy a backend, and it'll do some of the work for you. I just love it. So if you're looking for a way that you can actually deploy a website that only has front-end technology in it, gives you all the tools that you typically need for the back end without having to actually program the back end, then give them a try. Go check them out at netlify.com.
So tell us a little bit about your background.
So I've been into web development for a little bit over a decade. I've been working mainly with PHP and JavaScript, but also a lot of other languages. I think can quickly count maybe 8 languages. So I'm a little bit like a polyglot programmer, and I kind of like learning kind of principles behind different languages to kind of get the big picture of programming in all, so that I don't have this narrow scope.
That's a good point. When learning human languages, they say once you've learned your second language, it makes it easier to learn your third and fourth. I guess it's the same is true with programming.
Yeah, especially if you know a few C-style languages, it's pretty easy to learn the third one. Then if you go from imperative programming to functional programming, it's a little bit of a bigger leap. But if you work with modern JavaScript, you're already halfway there. So I think it's important to learn about the background, why things work in JavaScript today as they do, and what the ideas behind the concepts we have in modern JavaScript, where they come from.
Yeah. Oh, that's interesting. I have a bunch of thoughts on that, but I would like to ask you. So do you think the learning another language affects how you write the language you're working today? So if you learn, I don't know, a functional programming language, it affects the way JavaScript gets written?
I think it affects how you think about it. Especially when I was reading about ReasonML, I kind of got a much deeper understanding in why React works the way it works and why it requires the tooling that you usually use around it to make it kind of scalable for a bigger team or more performant or, more type safe and so forth.
That's interesting. So you're saying that it's actually we see that JavaScript, frameworks and libraries, are very inspired by these things that are happening in the other languages, and you're just going on the source of the knowledge to understand.
Yeah.
That's nice. Yeah.
Yeah, that's pretty much it.
Yeah, it's there are certain concepts that are almost impossible to learn without getting your hands dirty by actually doing something in a different environment.
Mm-hmm. Yeah.
Yeah, it seems like certain languages every language kind of has its own stuff that it considers normal, or the way to write code or something. And if you can borrow those ideas and come back, I think Redux started that way, right? Redux came out of Elm, and
yeah, I think it's Elm, and Script also had a React implementation, a React wrapper. I remember reading about this. Is interesting. I always tell people that if you want to learn about the future of JavaScript, you go on these languages around. Have a look at what's happening on ReasonML, have a look at what's happening, I don't know, Elm, Script. Now people are talking about algebraic effects, the Denimov thing. Yeah, so one thing that is interesting, it's you just declare your effects. The effects will be dealt in another place. This is not exactly what happens in Elm, but it's pretty much similar to what's happening there, and it's been happening for years. So this is really interesting. If you're looking at that, you'll be seeing the future. So that's a really cool thing to do.
Yeah, I think one of the hardest things I've learned in the past 5 years was to learn to kind of like write type JavaScript with flow type because the documentation was really sparse and was not very good. And understanding the concepts behind the typing was hard without having experience from a language like OCaml or some other like more type-safe languages.
Yeah. So did you come to that from like what was your language progression? You said you know a few of them.
So basically, I was doing I've been doing JavaScript for like professionally for 11 years, and I've been doing PHP for the same time. So I would say the closest thing before type JavaScript was like PHP 7.1 and onwards. And that's similar, and Java, of course, but it's not even, you can't even compare. It's more like you type your arguments and your return values. That's like so far away from like a strongly typed language, because you have like type in inference, and you have a lot of other things that work on so many more levels than you have in like a normal C-style language.
Yeah, the thing that got me interested in typing, because I used to be die-hard anti-types back in 2007 or so, and now I've come full circle, is when I started working at Facebook and they taught me the hack language, which added like progressive kind of optional typing features onto their own kind of flavor of PHP. I think some of that eventually got picked up into like PHP 7 and stuff. Probably. And I think the number one thing that got me was async await, because they had that back in like 2012 in their flavor of PHP. The productivity gains of having that typing just changed my life.
Yeah, I think it also makes for a much like easier to understand code, and you kind of like have this like guard in place. If you have the type safety, if someone changes something, they're gonna immediately notice that now something's wrong because I have an error here.
Yeah.
But it doesn't come like it comes with a cost, of course, like especially with Flow that Facebook updates like pretty often and keep like no change log. You should upgrade Flow. You have like 100 new errors you have to fix, and they're not actually errors. But luckily they improved the like error reporting and other stuff, so it's easier nowadays. But I still prefer TypeScript nowadays.
Me too. How'd you get into TypeScript? Because I remember like I was there from the beginning. I was obsessed with Flow as soon as it was coming out, on the bleeding edge of it, and I was just like so anti-TypeScript, and then I completely switched over and was like TypeScript all the way. What made you get interested in TypeScript?
I think too many projects are using flow type and like struggling with you know like complex typings, like typing higher order components and such, which can be very painful. So I thought like I'll give TypeScript a go, and I think it was TypeScript 3 already when I started using TypeScript, and it was kind of like on par with Flow. Of course, there's like some drawbacks, of course, but also some like bigger community, better documentation, more kind of like resources out there. So I think it kind of like draws the longer straw in that sense.
And it feels like every single project is getting either first-hand TypeScript support by exposing their own types from their own NPM modules, or there's the, whatever you call it, the third-party stuff where people type common libraries. What's that called again?
For Flow, it's Flow typed, but the TypeScript variant it's kind of like transparent because you install it through like the @types.
Right.
It was definitely typed.
Definitely typed,
That's
project.
Right.
Yeah.
Yeah, that's so huge. And it kind of has become a barometer of the legitimacy of some third-party library. If you pull something in and it doesn't have any TypeScript support, it's like, is this thing even supported anymore?
That's funny.
Yeah, well, I think there's kind of a thing that people, like at least early on, missed out, because it's not actually that hard to type third-party libraries, because you only have to type the parts that you actually use and like rely on those types. And like typing something like Redux is pretty simple, especially if you don't use any like complex stuff. And it's such a small library, so it doesn't take actually that long to type all the different things like reducers and actions and action creators and so forth. So I think that's not like a big problem if there's no typing available for some project. Like in ReasonML, there is so much less support for like bridging the JavaScript libraries to Reason, but it's actually not that hard to do either. So because you can do it the same way that you just like type the parts that you use, and then you can just pull in the code and use it.
I guess it's just not as much of it has already been done by the community.
Yeah, it's just like in an early stage, I would say.
There's another project that I looked really closely like about a year ago. I've not been following up. It's called Fable, which is Fsharp that transpiles to JavaScript. And they had an interesting tool. Fsharp is like almost like a different flavor of OCaml too. It's very OCaml based, but with the .NET stuff. It was interesting that they had a project that you can compile a TypeScript definition file to a Fable definition file.
Nice.
Of course, it's not like ideal because the type systems are very different, but you could get like most of it. So it's really interesting. You create like one language, and if there is the TypeScript definition, which is probably like the largest database of definitions out there, you could translate to your language. So this is an interesting thing.
Yeah, it's kind of like a code mod.
Yes, exactly.
Yeah.
So I guess for people who are still on the fence or who are still where I was back in 2007, diehard against typing, like what are the benefits? What do we actually get out of this other than just a feeling of superiority? Because there's definitely that.
Yeah, I think like one of the main things I would kind of like mention first too is kind of like the security you get in your code. Like you can refactor so much more easily, and usually like some developers have a really kind of like tendency that they don't refactor because they're afraid of breaking something. But if you have the types, you already have like some guards in place, so it's much less of a risk to actually change something. And I'm usually like, I'm the type of developer who usually, if I see something that could be improved, I go in and improve it instead of just leaving it. Of course, like in a case where it's like feasible, I don't go in editing everything that just because of fun of it, but I'm not the one who leaves like I'm not going to touch that because I don't know what it does. I'm just going to rewrite it in a better way instead. So I'm not kind of like that cautious developer in that sense.
I've been in a lot of layer-oriented programming projects that work just like that. You never touch anything that is already there because you're afraid. And then you just create like a small layer with the new functionality you want. And then you have like all these like Frankensteins because you're afraid of touching something. Yeah, definitely. The type actually helps. Like we need to be careful because sometimes, of course, Twitter is like 200 characters and stuff. People say like, oh, it's refactoring for free, right? You can just change and everything. There's a bunch of like pitfalls, right? You still need to be like somewhat aware that things like just because you said a function expects a string, it doesn't mean that the string is being passed to that function.
True.
In runtime. So compile time, it'd say like, that's fine. And then in runtime, it's not.
Yeah, it only kind of like mainly helps you right there when you're writing the code, but it doesn't actually ensure that your code runs in production. That's true.
It feels like it's automating a lot of the job that I used to do manually back in the day. And it was kind of a certain level of work that I didn't think about. Just anytime I make a change, just like read through all the code, think through all the paths. I was basically implementing a type checker inside my own brain and manually doing it.
Yeah.
But moving that out into the type checker, I think once I started working with more people, working with larger teams, and I just couldn't be on top of every single change that happened, to get that level of certainty that I know for sure that level of work is done. Just like the basics are covered and for free every single time any character is changed. So huge.
Yeah. It's also super helpful, I think, for smaller projects. Like I've noticed it's helped. Like I haven't written a whole lot of TypeScript because I think I'm probably in the same boat as you, Thomas. Like I was like, went from like C to like, and then like Ruby was like this wide open paradise where there weren't any types anywhere. And then I did Java and like, I hated types for a while. And then JavaScript and it was wonderful. So yeah, I feel like I've sort of resisted TypeScript, but I found it useful for like small side project type things that I don't touch very often. So almost like sort of counterintuitively, like instead of whipping it together in JavaScript, I've started building those things in TypeScript because if I go away for 3 months and come back to it, I can remember what the code does instead of having to like read through all of it and like, what does this function take? What
that is so huge.
Is this number? So like that kind of thing, being able to switch away, switch back and stuff, and just have confidence that things going to keep working.
I think like having a type system also gives you like the kind of like code intelligence. So you get like really complex auto-completion, like nested through a lot of layers, which isn't something that an editor can do. Like, of course, in like other languages like Java, it can do it for simple things. But with types, you can actually have it working like through the whole stack of your code.
And that's really the killer feature that got me to really take it on board. Just the productivity enhancement of, instead of opening up the source code of every single thing that I want to use, reading everything that could possibly happen, it's autocomplete for free. You can command click to jump to definition and actually read the types without having to sort through all of the implementation. It's such a huge productivity enhancement. I can't imagine working without it now.
And that's also, in my experience, when we talk about adoption, right? So let's say we have a company with big projects. Usually it's much easier to start from the leaves to the root of the application than the opposite. Like if someone wants to start working with types, it's so much easier to import something that is typed in a non-typed project than the opposite. Because I think this is probably like the thing that causes more noise is like, what are the actual types of this thing I'm importing? Like create these definitions are fun and stuff for people who know TypeScript. If you're trying to like work with people who like, oh, I still don't know this, I'm still need to be convinced. If you ask them to import JavaScript stuff into their TypeScript code, you're gonna lose these people. It's a pain in the ass to do like first. So the other like greenfield, small components stuff, like if you start with something with TypeScript, that's when you get like most of the benefits and understand this thing. And then you import into your JavaScript application and you get all the autocomplete and people are like, oh my God, this is good. Little by little. That's what I've seen like working for people actually starting to like TypeScript.
Yeah. Yeah, I think also like if we like in JavaScript, we like to work with like object literals for data, right? So having all those types, like knowing what fields you have on your object is a huge benefit over not knowing anything about it and letting the editor like make some decisions about like maybe this is there and maybe that is kind of like not there, but with the type system you get the type safety and you actually know like what kind of object you have and what fields it has and autocomplete and everything. So that's kind of like, I think, a huge benefit for me.
Would you say that it's better to write libraries in TypeScript?
Yeah, I would, because like imagine something like React Router and you use something like the history object and having like a working autocomplete with all the functions, like having everything typed. It's so much easier to work with that than having just to guess and look through the documentation, like what am I supposed to be passing into this and that, and you don't get any errors, and then you run your code and nothing works. So getting kind of that green light from the editor before even running your code is a huge benefit in my opinion.
Yeah, that's so huge because I've noticed the hardest things in life for me are guessing and thinking. So if I can get anything that can take away the need to guess and think about unnecessary things, and I can focus my guessing and thinking on things that actually matter, so huge.
Yep.
Yeah, and React Router in particular, like it always trips me up when you like push something onto the history object, and I'm just like, oh yeah, to push a string, I want to push a new route, and that doesn't work. It needs an object with like some stuff in it or whatever. So it's like a path name, and yeah, types help with that sort of thing.
Yeah,
finding your way around a new API.
Where I've been confused in the past of like, I want to write everything in TypeScript, but I also want to release like umpteen quadrillion NPM packages. I want to rival Substack, but I don't know how to actually like release an NPM package with TypeScript. Like, what am I supposed to be doing these days? Are there like rules somewhere?
It's a good question.
Yeah, I think the first thing you have to think about is like, you want to write your code in modern JavaScript, right? So you have to compile it down to ES5. or you have to transpile it. And there's like multiple ways to do that. Like most of us probably use Webpack, but it's more suitable for like projects than libraries. There's a lot of options. The one I've found like most useful when it comes to writing libraries is Rollup, because Rollup is so easy, kind of like much less configuration and so forth than Webpack, much less hassle.
I've heard of Rollup, but like what's the difference?
I think it's basically Webpack for libraries.
Oh, well, that's a good rule of thumb. If I'm doing a library, use Rollup. Boom, done.
Yeah, it doesn't like have a dev server or anything. Just kind of like configure it. What's the input, and then you just say like, I want these outputs. You can have like CommonJS, ES, or any other formats, and you can have like multiple outputs. And then it can have like plugins like TypeScript. So you can have input in TypeScript, and then you just package into CommonJS and ES6. So it's much like kind of like less work than using Webpack, which is meant for a little bit of different environment, in my opinion.
Right.
Yeah, I think that the rollup configs are really nice and easy to read. I've been seeing them because Svelte projects use them by default usually, like the Svelte templates. And I think rollup might be made by the same person. I think Rich Harris made rollup, or was part of the initial thing. But
yeah, it might be. Yeah.
Yeah, it's nice how lightweight that config is compared to the Webpack one. And I wonder why it hasn't spread more into regular individual projects versus libraries and stuff.
Well, I think one reason is probably like if you run code on Node, you can usually use almost all the new features if you have a new enough Node version. So you don't actually need a transpile step. And then if you're developing on the web, you usually need like a dev server. So Rollup doesn't really provide, as far as I know, it doesn't provide you with a dev server. It can just like take files and output files. It's like
so if I'm doing a library in TypeScript and I want to consume it in TypeScript, do I still have to transpile it to ES5 and CommonJS? And how does this, what are the norms nowadays? If everybody's using it from Node, does it still need to be compiled to ES6?
No, I think it was a while since I worked with like making libraries in TypeScript, but the thing you need is the type definitions, the D dot that it so that and you kind of like when you compile it, you get that with I'm a little bit like forgetting things, but I'm checking here a project that I built like before the summer vacation. I had a long summer vacation, so basically just like compiling with Rollup will create the definition file.
Nice.
And it will create like the different outputs. And then you still have to decide on like the directory structure. Do you want everything in one file but I've only done like small libraries. And there's like so many ways to do it. And the way I usually go about like when deciding how to like package my stuff is I look at public popular projects that are written in TypeScript. Like there's many, I think even like Redux is written in TypeScript nowadays. But there's a lot of different projects you can look at that has their source in TypeScript now. So that is kind of like the best source to find like a working build system for you. But you can probably opt out from some of the formats, like maybe the UMD package and some others you maybe don't need.
Yeah, I like to just follow whatever Jared Polymer's doing these days.
That's probably a good idea as well, yeah.
Yeah, what's the name of his project for TypeScript libraries?
Jared Polymer's stuff, like the latest thing that he released at the at ReactConf was the platform. So you can use the platform as a React hook.
Nice. It has a really good logo too.
Yeah.
Yeah, but I think he has a TypeScript, actually a TypeScript library building something. Yeah, I'm trying to find here.
Yeah, but I think like if you look at different projects, there's like a million ways to build your project. So
yeah, I just found it. It's the TSDX. Yeah.
Okay, I haven't heard about that one.
And now I heard that, what is it called? Next.js 9 has like built-in TypeScript support now.
Yeah, I heard about that as well at some conference, I think.
Yeah, I got to go read up on that.
And Apollo is also written in TypeScript.
What is?
Apollo.
Oh, really?
Yeah, I think they have like full TypeScript support now.
Very nice.
This is really interesting. One thing I think about when you have untyped language and you start typing things, the TypeScript approach is the one we've been looking at. In the closure, I've not also been following very closely, but I know that they have the closure spec thing, which is not types, but you define specs for the functions. So you put like some metadata in the function that says, okay, so this function's parameters, I'm expecting something like this. And you can put like even integer that is larger than 0, something like that. And the interesting thing is that you can then use that either for maybe only documentation. They use that to generate tests, which is really cool. Like they generate a bunch of tests for your functions, given the restrictions that you put on the inputs to make sure that the outputs are conform with what you said.
Oh, very cool. Yeah.
You can call like in function inside function. So they can also make like you can put like in dev, make runtime checks of the types. It's a different approach.
And what was that?
It's very interesting. It's called closure spec.
Closure spec. Can you use that in like regular JavaScript or TypeScript or whatever?
No. Because Clojure is also untyped language, right? It's also dynamic language. And that's the way things are going.
Okay.
More type things on their side.
It would be cool if you could do that in TypeScript. Just say, not only is this a number, it's a number that's, greater than this, less than that, whatever.
Yeah, this is a really difficult problem to solve in the typed world. Like even Haskell does not, like the super typed languages, strongly typed, even they don't have that. I think they're called dependent types. And it's like super recent, like academic stuff. They have some languages that have dependent types, but also there are like some old, I came across this language, I think it's called ADA, which was a language
I've heard of that.
in military stuff like for 30 years ago or something like that. That they have these type systems with dependent types that you could say like, okay, this is larger than 0, this is stuff. It's super difficult for a compiler to understand those things. So
you never know. We've got like the uber nerds working on all this stuff. I love that there are people obsessed with these kinds of things.
Yeah, it's complicated. Like even if you're in a super strong typed language and you have a function, for instance, give me the first element of array, like the input types of this function will be an array. You can't say like, I only accept arrays with at least one element. So that's the interesting thing. So some typed languages do like that. You can't do that.
Yeah, there's like tuples in TypeScript now, where it's like it has to be an array of this many items, and these are the types of the items in this array. And
yeah. Some of them, I think Elixir has pattern matching, and you can write guards on functions and say like, I only run this function when argument A is like greater than 7 or whatever. And so you can have multiple versions of a function. But I think that's not a runtime. I think that's like a runtime check. Like it'll check the argument and then call the right function.
Yeah. Okay. So since we are talking about these languages, let's go into the ReasonML realm too, because I know that you've been doing a lot of ReasonML lately, Christoffer. Am I right?
Yeah, just like looking into it and reading a little bit about it. There's actually like a pretty good free book about ReasonML. I can post a link later in the chat.
Yeah, I remember when I was, it's been a few years ago, like the guy who invented React, Jordan, is the one behind ReasonML. But what's interesting about Reason is that React actually started in OCaml. He designed it all in OCaml and then implemented it in JavaScript originally, but it was always his intention to get around to doing something OCaml-y. So ReasonML, and especially React Reason, is like the definitive version of React. It's just like from the future.
Yeah, I think it's React in its kind of like natural habitat. That is kind of like a good way to describe it.
Yeah.
There's like a lot of things missing from JavaScript, which you need tooling to cover. But in Reason, it's actually it comes with the language. So you don't have the same need for all of the different tooling. Like examples is like native support for immutability. You have the functional programming paradigm and like a fully blown type system, which you don't have in JavaScript. You can, of course, use TypeScript, but it's not the same thing. It's something in the same direction, but it's still not comparable with a strongly typed language.
So I think we skipped some of the context for people that might not be following. Can you describe like what is ReasonML?
It's basically a alternative syntax on top of OCaml. Like simply put, that is someone who is more technical and more into it might kind of like have a different reason, but I think it gives a good idea because it's a meta language. And it's just a different syntax, but it runs like underneath it runs OCaml, but it looks completely different from OCaml. And
yeah, OCaml code is just like, I need to go study math for 20 years before I can read this stuff.
Yeah, flow type is written in OCaml, so everyone can go check flow type's source code.
But Reason, like, it just looks like JavaScript. I can read it. It makes sense without really putting much effort into it.
Yeah, it looks a little bit like TypeScript, but kind of like Reason has a much better type, like support for inferring types. Like you don't have to actually, like TypeScript has a surprisingly good support for inferring types, but people still insist on typing everything. I usually like check, does this know that what kind of type this is? If it knows, then I'll just leave out the kind of like type definition, like defining the return type or something. If it's like a primitive, then it probably knows already that this returns a string. So you don't have to type it out. So
like in TypeScript itself, like the runtime can just guess what your types are half the time.
Yeah, it's called type inference, I think. So basically, I think the golden rule is that if you don't need to type it, don't write out the types.
Right, because then you're just writing Java at that point.
yeah, and also like it makes it kind of like much harder to refactor, and also like using type inference also helps in a way if you have something that can return like a union type or something like that. It might be hard to type it like strongly typed, just writing the types, but you might get away a little bit easier with having it loosely typed.
Basically, just let the computer do your work for free with zero effort.
Yeah.
Let's do that.
Seems like that's always the goal. If we can get to that.
So now I heard there's something that you can use to like turn ReasonML code that is like a thing on top of OCaml into JavaScript so we can actually use it in the real world. Not that OCaml isn't real, but you know.
Reason came before the tool that allows you to compile it, but it was kind of like a perfect timing for the tool called Buccal Script to be introduced. What Buccal Script does is it basically adds some JavaScript features like js.log or js.console and JS.date, and then also like JS string support, because OCaml doesn't use the same encoding as JavaScript, so you kind of have to have it's kind of like a little bit of a drawback, but you can work around it. And I would also like say that Reason is fairly new, and it's a little bit still, I think, in its infancy, like considering the adoption and everything around that. So I think there's still a lot of stuff coming into Reason that we don't even have today.
Yeah. But like in typical Facebook style, they're already using it in production as like part of Facebook Messenger. Because I think they wanted to rewrite some of that in Reason because they wanted absolute certainty that it was like bulletproof so they could scale and stuff like that.
Yeah.
Yeah, I've been hearing that like for a couple of years already. I wonder like how are they evaluating the success or not of this endeavor? Like is people using more or less Reason in their code base now? I wonder.
Actually, I asked a buddy of mine that works there, like not official, but one thing that they said is that it dramatically reduced bugs so that most of their development time is focused on features, performance, A/B testing, stuff like that. And just like a huge percentage of development time and energy and frustration was just like gone.
That's great. Yeah.
Yeah. I think like when you're writing Reason, you're writing a lot less code than when you're writing JavaScript. I think one of the reasons is language feature called pattern matching, which is like a switch case, but it's so much more because it allows you to kind of like rebind stuff and kind of like reuse whatever parts of the kind of data you got in and kind of like cover a lot of ground with just a few lines of code.
Mm-hmm.
It's a little bit like matching like a switch case on steroids. So you could match like if the arguments, let's say if you have like a vector and that has a...
What's a vector?
Or let's go with something more simple like a point where you have X and Y coordinates. You can make a switch case where the coordinates are 0 and 0. And then you can catch everything with a catch-all, which is underscore. And if it doesn't go there, then it will go to the catch-all. But if you leave out the catch-all and it takes in something else and a point with 0, 0, you will get an error and it won't compile. So you kind of get so much more safety.
You need to deal with all the cases in a pattern matching or else to get an error. This is really good. Yeah. How many times have you seen like a function that has like a enum or something that you created as an input and some item was added to that enum 6 months later, and then the functions are breaking, you don't know why. Yeah. It's because, so this is the type of thing. So this is interesting. The type inference part is a byproduct of having like a strong type system that helps you with those things. So it's more like a really good helper. For me, that's the interesting part of using Reason with React. It seems that the language has enough features that you don't need to bring what people call React and friends, right? It's not always React. You know, you need to, if you want some more reliability here, you need to use like immutable.js or immer.js. If you need something else here, you need to use this other feature or the thunk or the blah, blah. It seems that the features of the Reason language makes it easier to actually use React. Yeah, it's a little bit, it's counterintuitive in that sense, but it's
then great. There's less code to write, less code to maintain, less code that can go wrong, fewer bugs, like it just across the board is such a huge win. And
the compiler is really good too. And since the types are, since you have a lot of certainty around the types, there's a bunch of code elimination during the compiling time. So even like your deliverables are smaller because like your JavaScript deliverables are smaller. If you have like a private variable that is not used outside a module in ReasonML, you don't get that code in your output JavaScript, which is a thing that like it's real code elimination if you think about.
Yeah, it's like a tree shaking thing, right? That Rollup and Webpack do, but it's probably a lot better because it can be like 100% sure.
Because you have some guarantees from the language. Yeah. Like you can tree shake, for instance, a property of an object in JavaScript. So if you create if you export an object, like because like you really don't know who's gonna use that, like everybody can use it.
Yeah, you don't know, and there's all these different ways of dynamically accessing it and stuff.
You can't. Yeah. You just can't. And with Reason you can. So just eliminate. One thing that is really cool, go to the Try Reason website and play with those things. It's interesting the way it eliminates code like crazy.
I guess my biggest question is, like, if I'm not on the Facebook Messenger team, can I use Reason and somebody pay me to do it? Like,
yeah, that's adoption. You definitely can use TypeScript, right?
Oh yeah,
but
seems
what
like
about Reason?
Most JavaScript jobs are TypeScript jobs now.
I think or I would guess that there is probably a few companies that are actually like also looking into Reason, if not already like replacing parts of their code base, maybe like a small portion with Reason just to try it out. I think there's multiple companies that are doing that, but I think it's more of like a future thing. But I kind of like to keep kind of like it's an old language in the sense it's years old, so it feels like this already like an old thing, but adoption takes so much more time than people think. So actually, if you get on board the Reason train now, you're actually pretty early. There's still a lot of people who are like, I'm never going to look into that. I'm just going to be writing TypeScript. And in 2 years, it's like everything is Reason. Maybe not, but there's a possibility that it will kind of like take over the React ecosystem in some years, at least partly.
And another reason, to consider Reason and TypeScript actually is you can now compile Reason or TypeScript to WebAssembly. And WebAssembly is like ridiculously well supported in browsers now.
Yeah.
And then, you know, depending on what it is that you're building. Actually, I'm not sure if you can do WebAssembly with Reason yet. But I heard rumors that that was going to be a thing. But I know there's like some flavor of TypeScript that is, it's officially not TypeScript to WebAssembly, but it is. I mean, depending on what you're doing, I know like Figma, the design app, uses a lot of WebAssembly. But that's very interesting to think about. Okay, what could I write in WebAssembly that would just be ludicrously better performance? Maybe like a, like what's it called? The constraint solver algorithm, cassowary, something like that. I don't know.
Yeah, I think, far as I know, WebAssembly is used pretty much also for like graphics things with like kind of like processor heavy or GPU heavy things. Because it has much better performance than any other way of doing it. But I haven't worked with WebAssembly. It's been on my to-do list for a long time. But I think something like Reason is much more kind of like high level, and it's also like conceptually more interesting, I think.
Yeah, but
when it comes to like principles and other things. So that's why I kind of opted for going with Reason at least before looking into WebAssembly. But I know that some front-end engineers even are saying that WebAssembly is really cool. So it's probably something we should look into.
what I like about TypeScript and Reason is that writing in these higher level languages, then either JavaScript or WebAssembly or even just like actual assembly, native bytecode or whatever, is just a compile target. That instead of writing something that's implementation specific, like if you're writing JavaScript, it's only really going to run in the browser or maybe in Node.js, but you can't compile JavaScript to anything else. But if you're writing in TypeScript or writing in Reason, then you can compile that to something binary, something, you have more options as far as like future proofing it, compile targets. With the kind of the way that Facebook sold React Native was not write once, run everywhere, but learn once, develop anywhere.
Yeah, that is true. But I think like we touched the subjects of what you get like with React Reason, like compared to using like JavaScript version of React. And I found this list. There's like it's pretty short, but you know, you have the static typing as mentioned. You don't need that. It's built in. Immutability, you also have that, but it's optional actually in Reason, but you have it built in. As according to this list, you actually have routing also built in, so you don't need React Router. Prettier is also built into the Reason ML core, so it has auto formatting as well. And then you have the linting. It's also something that is already built into the language. And then you have a pretty good standard library. And I think one thing that is pretty cool with Reason is that it allows you to override the standard library, like parts of it, if you want to. You just have to have like certain files, and they're going to overwrite the standard library or any other libraries that you might be using. And also you don't need any imports, or kind of you do need imports, but you don't need to import any files. You can include modules, but that's kind of like a little bit of a different thing. But you don't need all these import statements as you have in JavaScript, like tons of imports on top of every module. In Reason, it's so much easier because you don't basically need anything. It's all kind of like already available right
That's
there.
pretty awesome.
Yeah, with autocomplete and everything. So it's pretty neat, I think.
Nice.
That's amazing.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
let's go to picks now. Thomas, do you have any?
Yeah, so the thing that I've been hacking around with lately is Brian Vaughn's rewrite of the React Dev Tools. They're getting to be super, super slick. You can install them and use them right now. And there are just so many ridiculously good features, as well as like a better profiler, all this stuff. And you can use it now and then give him feedback.
That's amazing. Dave, do you have any picks today?
Yeah, I saw a thing called Smash Test recently. It's like a new language for writing pretty much like end-to-end tests. So it spins up Selenium and runs browser automation for you. But the cool thing is that Smash Test, you can write your tests as in like this plain text format, kind of readable if you use like Cucumber or something. It's similar to that maybe, where you can tell it like which browsers to use. And then it's this indented format where you say, for Chrome and Safari and whatever, visit this page, then fill in the thing, and then like click a button. And it will explode that into all the different permutations. So you end up, and it generates the JavaScript code for you. So you can write this like pretty concise thing and it'll generate, 50 different tests for all the different browsers, all the different inputs you wanted to try. It's really cool. So smashtest.io.
That's pretty slick.
Oh,
yeah.
That's really good. Yeah. Generative tests.
Yeah. It's a cool idea. It's one of those ideas that's like, oh yeah, well, don't we do this yet? Like this, obviously we should do this.
Nice. Does it run in Selenium underneath it?
I think it does. I think it's using WebDriver or something, yeah.
Uh-huh.
Yeah, the format is pretty neat. I looked at the sample test here.
Yeah, super cool. Yeah, my pick for today is thinking about complex systems, dynamic systems, and all that. Seems to me that is like one of the best ways of thinking about software building software in the scale that we do. Things get crazy, and whenever I read about complex dynamic systems, I feel that I'm understanding a little bit more about the chaos that is happening around me in software, all the crazy things. So I found this website called Complexity Explained. So it's a small, beautiful website that explains like the main concepts around complexity theory, like complex systems theory. And it's really cool. It's beautiful. It has like some interactive examples, bunch of reference. It's a really interesting like intro to complex systems and systems thinking and this kind of thing. It's a really interesting like mental tool to think about software and to understand why things are the way they are.
Interesting.
Yeah.
That sounds like the next 6 months of my life.
No, it's not that. Yeah. If you go the rabbit holes, you can say this next 6 years of your lives.
Yeah.
But like it's really cool. Like in 10 minutes you go through like the 5 main concepts. They have these cool examples. It's really great. So what about you, Christoffer? Do you have any picks?
Well, I've been on a pretty long vacation, but I would say that the Reason book is the first thing I would.
Nice.
Anyone who's working with React. I posted a link, so it's on Reason Hub.
Nice.
And it's called reasonmlhub.com/exploring-reasonml. And you can read it for free.
Nice.
Online. It's pretty good. And I would say that it's been a little bit like mind-boggling because like reading about the variant types, I had to read the chapters a few times before I kind of grasped the concept. It's not the most like kind of like you have to be in the right mind to read it. You really have to take it in. You might have to read it a few times, but after that you're gonna be like, what doesn't other languages have these features? So really, really encourage everyone to take a look at the book and give it a try.
Yeah. There was one concept in ReasonML that I did not find like in any of the other languages that I've studied a little bit, which was this polymorphic variant thing. And this book was this chapter that I think made me understand it.
Yeah, it's kind of like a tricky concept, I would say.
Yeah.
Yeah, because in ReasonML, like if you have like a variant, it's basically an enum, but all of the values are actually constructors, so they can take arguments. So you can have like a type called shape, and it can have different values like circle, rectangle, triangle, and so on. And with the polymorphic variant types, you can kind of like type them as you go. You don't have to define them before. But I think also like one complexity that I've noticed with Reason is the same that you have in many languages. Like you have so many different concepts, and actually knowing when it's worth to take the kind of drawbacks you get from whatever kind of like concept you choose, when it's actually like worth it. That's kind of the tricky part, I guess. And I think the book gives a pretty good understanding of what you should kind of steer clear of. What are the good practices in? Like,
that's huge.
Yeah, and I think that's a really, really good part about the book, that you learn about all these complex concepts, but then you also like learn that maybe you should kind of like steer clear of these unless you're making something that you expect to be extendable. And you probably all know that some people like to write extendable code by default, and that's usually very time consuming and usually like very unnecessary. So I usually go for the
hard way.
yeah. I usually go for like writing the local code as it is, and then refactoring later if I notice that there's some similarities or overlapping code. Or like the most usual thing is that I split it into smaller parts to be able to use it. That is kind of like my way of doing it. And I've been writing like quite a lot of different smaller open source projects. My biggest one, I think, was a GraphQL implementation in PHP 7.1, which is on GitHub. And
nice.
That took quite a while to write. And there's been a lot of refactoring and a lot of like thinking about how the API should look and how the internal API should look and so forth. So I have some experience in writing extendable code, because the current de facto PHP implementation of GraphQL is not extendable. Maybe if you like replace a lot of the code that they wrote, but it's not built to be extended. And I think that's a kind of like disappointing in my opinion.
All right, this is great. So yeah, thank you very much, Christoffer.
Yeah, thanks. It was really nice to be on the show.
Thank you very much. And thank you, Dave, and thank you, Thomas.
Thank you.
See you next time. Bye-bye.
Yep, bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.